Alright, so this will be my first attempt at recording a lesson, so y'all just bear with me. And if it gets out of focus, I'll freeze and let it focus back in. But today, since I'm not in class, you're going to be watching a video of me presenting this lesson. I'll try to pause as much as I can to give you chances to write stuff down or whatever the case may be. But we'll go through the lesson, you'll take notes, and then at the end, whether I'm in here or not, your assignment is on the board. Please don't give any problems, and if something happens with the computer, help whoever is in here out and let them or help them get through this. All right. So today we're looking at comparing properties of functions. All right. So it's a lot of the same things we've been doing. You're going to be looking for slopes and slopes and y-intercepts. Okay. The big deal is when it says compare, folks, that means that you're going to have to write sentences. Okay. It doesn't have to be overly crazy sentence, but comparing means you're comparing one to another. All right, and you're not able to do that without writing a sentence. Okay, so we're going to look through this together. And if you have any questions, if my explanations don't answer them, just do the best you can tonight, and I'll make sure to answer them tomorrow when I'm back in class. So the first one, we're looking at a real-world link. Okay, Carlos and Stephanie belong to a science museum. Carlos' membership can be represented by the function C equals $9.99, where C represents cost in dollars. The cost for Stephanie's membership is shown in the table right here. Make a table to represent Carlos' membership. All right. So we're going to make a table to represent his membership. His is represented by C equals $9.99. That means no matter what, no matter how many months, he's going to pay $9.99, period. Okay. So at month 1, month 2, month 3, and month 4, his cost at month 1 is what? C equals what? $9.99. Okay. Cost at month 2, C still equals what? $9.99. You see the picture here. Every month, no matter what, his cost is going to equal $9.99. It's because his function here, C equals $9.99, does not have a rate of change that we're having to multiply the months by. Okay? So in that case, it's just C equals $9.99. Alright? So, on number 2, it says describe the rate of change for each function. Okay? So to do that, we need to find the rate of change here for Stephanie. Now, Stephanie's each month is going up by how much? Each month is going up $5. Okay? And if you look, they're counting up by what? Ones. So that means her rate of change in this problem is 5. Her rate of change is 5. 5 over 1 or just 5. Okay? Where Carlos's is going up by how much? Every time it's going up 0. That means that their rate of change, or Carlos's rate of change, would be what? And it would be 0. So we know the rate of change for Carlos and for Stephanie. Now we're going to describe this for each function. Okay? So we'll say Carlos's membership has a rate of change of $0 or 0. It means his rate's not going to change. Okay? Every month, that's what he's going to pay. All right? Now, the rate of change for Stephanie for her membership, okay, is how much is it going per month? How much is her membership per month? And it's $5. $5 per month. Okay? So, we know that Carlos is going to pay $9.99, period. He's going to pay $9.99, and that's it. Now, Stephanie's is going to be $5 per month. So, if she wanted a 3-month membership, she would have to pay $15. Okay? So, who pays more for a 2-month membership, and explain? What you're going to do is you're going to look at the two tables and find out who pays more. And it shouldn't be too hard. Stephanie's table at 2 months is $10. Carlos is $9.99. So who pays more? Exactly. It's going to be Stephanie. Alright? It's going to be Stephanie, and you got to tell me why. Okay? So Stephanie will pay more. She'll pay $10, while Carlos only pays $9.99. Therefore, Stephanie pays more. Okay? Then the last one, you're saying, who pays more for a 6-month membership? Okay? There should be no question that Stephanie's going to pay more. Alright? As we can see, Carlos is not going to pay more. His cost is not going to change, but Stephanie's is going up. So, Stephanie's going to pay more. Okay? But let's talk about how much she's going to pay. So how are we going to find out how much she's going to pay? Well, each month she pays how much? How much is it going up by? And that's 5. So at month 6, how much will she pay? Okay. How would we find that? Stephanie will pay 6 times 5, which is $30, while Carlos is still going to pay $9.99. Okay? So we're just using the two rates of change to answer some questions. All right? Hopefully everybody's catching on. But really, the main thing today, we're going to be looking at rates of change and initial values or y-intercepts. Okay? Make sure that you're doing both, because when it starts asking you to compare both, you're going to have to find the rate of change and the y-intercept. If you don't find the y-intercept, you're not going to be able to compare it. All right? Everybody should have all this copied down by now, so we're going to go to the next one. All right, so the example 1 here, okay, which is done for us, says a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph to the right shows the speed of the zebra. Compare their speeds. Now, we know from what it just said, we know how fast the lion can run. We've got to find out how fast the zebra can run so we can compare their speeds. Now, how are we going to find out how fast a zebra can run given a graph? Okay? The only thing that we should know how to do is do the what? Slope. Okay? The slope or the rate of change. It's the same thing. What do you need to do the slope or the rate of change? 2 points. Okay? Any 2 points will do from the graph. They chose the first 2 just like I tell y'all to. Now, it shows you that they chose these 2 and they found that the zebra, okay, the zebra can run at 59/1, which is 59 feet per second. So, when you compare, again, got to write a sentence. A zebra can travel at a rate of 59 feet per second. Since 59 is greater than 53, that's the comparing part. You're saying that this one's greater than that one. The speed of the zebra is greater than the speed of the lion. That's when you're comparing. Okay? It's great that you found both their rates of change, and it's important, and you have to do it. But if you don't have a comparison sentence in there, you didn't compare. All you did was found the two rates of change. Very important, but we have to do what we're asked to do here, and that's compare. Okay? So now, let's do it on our own. Okay? And if this gets out of focus, I'll stop and hopefully it'll focus back in. So just bear with me. A certain car has a gas mileage of 22 miles per gallon. The gas mileage of a certain sports utility vehicle is represented by the function shown to your right. Okay, the graph right here. Compare their gas mileages. Okay? Well, first off, the car, its gas mileage is what? 22 mpg. Now, for the SUV, we don't know it yet. What are we going to do with these points on this graph to find the gas mileage? We're going to find the slope. Okay, given 2 points. We're going to use the first two. That seems to be the easiest two. More times than not, and since we're dealing with lines, we don't have to choose any more than the first two. Alright? So, we find the slope. We got x1 and y1, x2 and y2. So if you struggle with slope, guess what, guys? It's not going away. You're going to have to learn how to do it. M is equal to y2 minus y1 over x2 minus x1. y2 is 38 minus 19 over 2 minus 1, which is 19 over 1. So the SUV is 19 over 1. That means 19 miles to the gallon. So we see the car and the SUV. Now we're going to compare. Okay? We're going to have to write a sentence. The car gets 22 miles per gallon. Okay? While the SUV only gets 19 miles per gallon. Okay, now you've told the rates of change for both, or their gas mileage in this case. We have to have a comparison sentence. Okay, so we'll say since 22 is greater than 19, the car has a greater gas mileage. Okay, I'll give you a second to write that down. So, while you're writing this down, we found the rate of change given in this. We found the rate of change given the graph. We list out what they are. The car's rate of change and the SUV. In this case, it's miles per gallon. Then that last sentence is our comparison sentence. When I tell you, or on your homework, or on a quiz, or a test, or anything, and it says, compare this, compare that, you must write in complete sentences. If you don't write in complete sentences, it's not correct. Period. There's no arguing it. You have to write in complete sentences. Okay? Since 22 is greater than 19, the car has a greater gas mileage. Okay? That's comparing. Alright? I'll give you a few more seconds to make sure you have everything down. Okay, so we're going to move on. Alright? So far all we've been comparing is rates of change, and that may be what we stick with for a little bit. But, actually in this one it says compare y-intercepts and rates of change. So now we're comparing both. Okay? And then we might have to find a distance at some point. Okay? So on this one, we got the function m equals 140h, where m is the miles traveled and h hours represents the speed of the first Japanese high-speed train. The speed of a high-speed train operating today in China is shown in the table right here. Assume the relationships between the two quantities are linear. That just means they're both lines. Okay. Compare the y-intercepts and the rates of change. So, looking at this equation here, there is no y-intercept. It's not shown. There's not a plus anything. So we assume that that is what? 0. Now, before we can do anything with this one, I would advise you to go ahead and try to write an equation like this for the one in China. You again have to find the rate of change. But since this is going up by ones here, how much did it go up by here? And there's your rate of change. 434 minus 217 is 217. So our rate of change here, or our equation, will be m equals 217h. And then again, it's plus 0, because if the train hasn't traveled any time, it's not gone any miles yet. Okay? So when it says compare the functions y-intercepts and rate of change, you're first going to compare the y-intercepts. At 0 hours, no distance has been covered. So the y-intercepts are the same at 0. And that's done. Now, what it's going to show you is how they found the rate of change here. We've already done that. Okay? But it's going to show you again. The Japanese train is the speed of the Japanese train is 140 miles per hour. We see that right here in the equation. Use the table to find the speed of the Chinese train, which was 217. Okay, and then again, that all-important sentence of comparing, because you're comparing. Since 217 is greater than 140, the function representing the Chinese high-speed train has a greater rate of change than the function representing the Japanese train. Okay, you could also shorten that up to just basically say, since 217 is greater than 140, the Chinese train has a greater rate of change than the Japanese train. Okay, that's fine. All right, now on B it says if you ride each train for 5 hours, how far will you travel on each? This is why I wanted us to write the equation for both of the these. Now, this one was already given. This one was not. Okay? That's why I wanted to write it, though, because instead of having to extend the table, now, since we have two equations, we can just plug in for hours on both and find how far they've went. You'll see down here. For the Japanese one, see, all they had to do was say m equals 140h, plug in 5 for the hours, and say that m is this train has traveled 700 miles. You will travel 700 miles on the Japanese train. While here, they're extending the table. Instead of having to extend the table, we can just do the same thing with m equals 217h. We can say m is equal to 217 times 5, which was the hours that we're trying to find, and say m is equal to 1,085 miles. Okay? So we're able to say that you would travel 1,085 miles on the Chinese train. All right? Okay, so if it doesn't give you an equation, guys, and we need practice on this, because I think everybody at one point or another struggles at writing equations, given tables, graphs, it doesn't matter. All right? We need to practice on it, so let's practice it. We're going to be writing equations, period. So if it doesn't give you an equation, write one. All right? Okay, let's try one on our own now. The number of movies a store receives can be represented by the function m equals 7w plus 2, where the m represents the number of movies and w represents the weeks. The number of games the same store receives is shown in the table. Compare the functions y-intercepts and rates of change. Now, this one's already got an equation. This one does not. Okay, let's try to find the equation. First off, we need the rate of change. It's going up by 1. Every week is going up by 1, and the number of games is going up by 3. So the rate of change here is 3 over 1, or just 3. What's the y-intercept? Well, if at week 1 they had 3, at week 0, they would have how many? Sorry, that should be a B, not a Y. And you're correct. It should be 0. They don't have any games yet. So now we're going to compare their y-intercepts and the rates of change. Okay, so we're going to say that the store starts, okay, with 2 movies, because there's a 2 here, which is the rate of change for movies. It represents movies. With 2 movies and 0 games. Which are shown as the y-intercept in the functions. Okay, now we do have to talk about their rates of change. Now, the rates of change for movies would be 7, where the games would be 3. That means they're going to add more movies every week than they do games. We're going to have to write that in too. Alright? The store adds 7 movies a week. Oh, I'm sorry. 7 movies and 3 games each week, seen or as seen in their equations. Okay? All right? Now, that's comparing. All right, you do need to put in here that the movie's rate of change is greater. All right, and so the movie's rate of change is greater. That's comparing. Now, I know that's a lot, but that just is what it is, okay? You're going to have to write a good bit. Now, it says, how many new movies and games will the store have in week 6? We're going to work those out right here because we are out of room over here. All right, so for the movies, we'll have M equals 7W plus 2. And for the games, we'll have G equals 3W, and that's it. No plus or anything, okay? Because we have a rate of change of 3 and a y-intercept of 0. All right. Now we're just plugging in 6 for W on both. So M equals 7 times 6 plus 2. 7 times 6 is what? 42. Plus 2 more is 44. So 44 movies. And then games will be 3 times 6. So 3 times 6 is 18 games. Okay? I'll give you a second to write all that down while I talk. So on B, you had to compare the rate of change and the y-intercept. Okay? It's a lot to write. I get that, but it is what it is. You have to write. All right? There's nothing we can do about it. You just have to do it. All right? Once you write what they all both mean, make sure you compare the rates of change and the y-intercepts. All right. And then on C, this is again why I want you to write the equations for both. I don't want you to have to worry about extending this table out to 6 weeks. All right. If you have an equation, it's just substitute in and solve. And we're much better, I think, at substituting in than we are at trying to extend a table. Okay. write an equation that'll give us practice at that, and then substitute in and solve. All right, questions for that? All right, if there are any, hopefully somebody in the class can maybe help. If so, do so. If not, and if there are no questions, then great. But if there are questions and nobody can answer it, just make sure you ask me tomorrow. Okay. So on 3, it's the same thing. Okay. You're comparing y-intercepts and rates of change, except this time instead of a table, we've got a graph. Still have a word description and a graph. Okay. Angela's monthly cell phone bill is represented by 15 cents per minute plus $49, where Benjamin's monthly cost is shown in the graph, and there's Benjamin's cost. You're going to compare y-intercepts and rates of change. Okay, I'm telling you, if you will go ahead and write an equation for this, it'll make your life easier. But if you don't, you know, there's not much I can do for you. I'm not able to make you do it. Okay, it's just a suggestion, basically. So it'll show you how to in this case, but the y-intercept obviously is 60. That's where it starts. Okay, and then you just have to find the rate of change here. All right. And then let's see. So you compare them. You say the Angela's bill has a y-intercept of 40, and then you can see the graph that the y-intercept for Benjamin's is 60. So he has a greater initial cost. There's that comparison sentence. Where the rate of change for Angela's is 15 cents per minute. You got to find Benjamin's rate of change. It's just finding the slope again using 2 points. Okay, so they find the slope, and it's 10 cents, 0.10. So that means the rate of change of Benjamin's bill is 0.10. All right, 10 cents per minute. So Angela pays more per minute, but Ben pays more for the initial fee. Okay, so you've compared both. And then part B wants you to find the monthly cost for Angela and Benjamin for 200 minutes. This is where if you write the equation for Benjamin's, it'll make your life easier. Okay? It will make your life easier because it may not always tell you exactly it. Now in this case, Angela's, you just take their equation and plug in 200 for X. You'd have 0.15 times 200 plus 49 is 79. Okay? And then on this one, it told you, if you just look at the graph, it told you that at 200 minutes, his bill was $80 right here. It's at the very top of your page, or on the screen. It's at the top of this example. At 200 minutes, his bill is $80. It may not always do that, folks, and it's lucky that it did on this one. Otherwise, you need to have that equation so that you can just substitute in for 200 minutes and then solve it. Okay? And if you want to know what that equation would be, you take the rate of change, so Ben's, okay, the rate of change is 0.10. You got to times it by the minutes and then add in their initial cost. His y-intercept, or his initial cost, was 60. There's your equation that you can plug in 200 minutes in and just solve for that. Sorry. Okay? I know this is a lot, folks. This is a heavy lesson. That's why I'm doing this video. That way, I know I'm not in here, but at least I'm able to explain it rather than just writing all this down and letting you copy it down. Okay? So you're going to have to do the best you can on your homework tonight, and then I'll answer all the questions I can tomorrow. Okay? All right, so let's look at one together. All right? We got, we really got this example that we got to do together, and then one more that's going to talk about it. But this will be the last one that we actually have to do. Okay, so we're comparing y-intercepts and rates of change. It's the same thing as we just did. Okay? Financial literacy. Mandy and Sarah each give a membership, or each have a membership to the gym. Mandy's membership is represented by the function y equals 3x plus 29. where X is the hours with a trainer and Y represents the cost. Cost of Sarah's membership is shown in the graph. Okay, like I said, I'm telling you it's best for you if you just go ahead and find the equation for this. So that's what I'm going to tell you to do. Find the equation. The y-intercept's easy. Okay, the y-intercept is easy. I'll do it right here. We got to find the slope and the y-intercept. The y-intercept's where the graph starts. Where does it start at? How much does she pay before she ever walks in the gym? That's $40. The slope might be a little harder for you, but it's still finding the rate of change, okay, or the slope of the line. So it's you got to find slope, which is, I'll do it right here. You have 0.39 and 54.51. X1, Y1, X2, and Y2. We got M equals Y2, which is 51, minus 39, over 4 minus 0. Okay. Okay. So 51 minus 39 is 12. 4 minus 0 is 4, which simplifies to a rate of change of 3. So her equation would be y equals 3x plus 40. Now we've got two equations here. We've got y equals 3x plus 29, y equals 3x plus 40 that we can refer to try to figure this out. Now, we're going to talk about their y-intercepts first. All right? So, Mandy's membership fee is $29, while Sarah's is $40, and we're seeing this from both our table and both our equations or the equation and the graph, whichever one you're looking at. Okay, whichever one that you're looking at, that's what we're trying to find. All right. We need to specify that the fees represent the y-intercepts. Okay, that'll just let everybody know that you know why you're talking about the fees when it says compare the y-intercepts. Okay, and then you got to compare. So who pays more, 29 or 40? So Sarah pays a greater fee. All right. So we need to talk about their rates of change. What are their rates of change? In this one, it's what? 3. And in this one, also 3. So that means they're the exact same. Okay? So we can say something of this nature. Both Sarah and Mandy pay $3 per hour. With the trainer. So their their rates of change are the same. Okay? So even though they have different membership fees, their rates of change are the same. Okay? Now, on part E, we're finding the total cost for Mandy and Sarah if they both train for 4 hours. This is where we're going to use our equations. So for Mandy, we're using y equals 3x plus 29. And for Sarah, we're using y equals 3x plus 40. So Mandy's will be y equals 3 times 4 plus 29. 3 times 4 is 12 plus 29 is $41. So Mandy is $41. And then Sarah is y equals 3 times 4 plus 40. 3 times 4 is still 12, plus 40 more is $51. Oh, I'm sorry, $51. We made a mistake. Okay? I made a mistake. I assumed, this is my mistake right here, I assumed that this was at 40. I got to pay attention, so do you, because this is 100% my fault. Okay? The y-intercept here is actually not 40. Okay? And that's my fault, I'm sorry. At hour 0, it's actually 39. Okay? I was wondering why my math wasn't working. So we got to change everything that says 40 to 39. So that just goes to show you that if you assume something by looking at a graph, you may get it wrong. That's my fault. If it causes a problem, I'm sorry, but just make sure that you look. It looks to be 40, and I assumed it's 40, but right next to it, that point, 0, is at 39. So the y-intercept is actually 39. It doesn't really change much other than right here, but you just need to make sure. So Sarah's, needless to say, is $51. Okay? Sorry about that. So I'll give you a few minutes to make the changes, but we're almost done. There's just one more example, and we don't have to do anything. I'm just going to quickly talk through it. And then your homework, you made to make sure that you do not do the guided practice page. Your homework starts on the independent practice. Okay? Your homework starts on the independent practice. All right? So one more example that we're going to talk through. It's talking about movers, and you're trying to decide which company she could use for 40 miles. Okay? And it doesn't even say, let's see, it doesn't even say to compare or contrast. All right? You're just trying to decide which one she's going to use. To do that, guys, you take Crosstown and you take Ron's. All right? And it's all written out right here. I'm just going to give you the short version. You can read through this if you want on your own. You need to make equations for both of them, which they're given below if you look. All right, you need to make equations for both of them. Find the y-intercept of Crosstown, which is 30. Find the slope, how much it charges per mile that you're driving. Okay, do the same thing here. And then once you have the two equations, which is what we've been working on, all right, once you have those two equations, okay, you're going to, excuse me, you're going to say, okay, I'll take the two equations, I'm going to plug in 40 for x and solve, and that'll tell you how much it's costing. Now, they do it differently. They extend the table here, but for Crosstown, they do the equation. So if you're wondering on how do I write the equation again, it's listed, it's shown right here. You could do the same thing for this. Now on this, they just extend the table because it's going up by tens. So 10, 20, 30, 40 would just add $25 more, which is 100. And then once you find who would be the better price, you have to say, so Crosstown movers in this case would be the better option. You probably know that based off just looking at this table here, because at 30 miles, they're charging 75. At 40 miles here, it hasn't got to 50 yet. So you should be able to just look at that and see. But sometimes you may not be able to. In that case, write an equation for all of them, plug in, see who's the highest. All right? That's it. You can start on your assignment. Please don't give anybody any trouble if I'm not in here. If I am, I'll continue on telling you what to do. But if I'm not in here, get your assignment going. Don't cause any trouble. And if you have any questions tomorrow, I'll do my best to answer them. All right? Thanks, guys.